Hello and welcome back to Nick Does Algos. In this lesson, we'll be covering the Hackerrank Easy Rated Algorithm Halloween Sale. Happy Halloween, by the way. Mere coincidence that I wound up doing this problem on this day, but happy Halloween. Okay, so what are we working with? We are working with a person who goes to a game store with a certain amount of dollars. In this first scenario, he's got $70 to spend. And how this sale works is the first game costs full price, and every subsequent game costs the full price minus the discount. Sorry, not the full price minus the discount, the last price minus the discount. So if your first price was the initial, the second price would be the initial minus the discount of 3. And then the next game you buy would get another discount, and it would be 14, as you can see here. And the next one would be 11, and the next one would be 8. And then you hit this floor, you hit this minimum number. That number is the minimum you can pay. It does not get cheaper after that. So if you had this 8, and you went to apply another discount to get 5, you would go underneath that floor. So you can't do that, but the next one would cost $6. And then all subsequent games would cost $6. So once you reach that floor, you stick to it, and all the games after that cost that much money. And this first example, you have $70 to spend, as I mentioned, and well, it turns out the cost of these first 5 games up until the 8, these first 5 games, that would cost $70. So you would go ahead and return 5 for 5 games. You were able to buy 5 games. So that is it for the most part. Let's head over to Hackerrank and get to work on an example. So here we've got similarly all those same numbers besides the S. S is 80 in this case as opposed to 70. So what would we first want to do? Well, at the end, we're going to return the number of games we bought. And the number of games we buy depends on how much money we've spent. So what I'm going to do is create a paid array. And this will show how much you've paid for each game that you've purchased so far. So using those values, we can keep track of how much we've spent. And then at the end, you can return the length to show how many games you've actually purchased. So that's why we're going to stick with that. And we're also going to use a counter. And we're going to use a counter because the counter is going to help us keep track of the current price that the game will cost. As the counter goes up, we will subtract the discount. Each time the counter goes up, we will subtract an extra discount to keep track of how much the current cost is. And then, of course, once we get to that minimum, we'll stop doing that, and we will just use the minimum for the remainder of the games we can buy. So we've got those set up, and next we'll set up a while loop. And as I said, this is all of our math is going to happen while the sum of the paid array is less than S. While the sum of what you have paid is less than what you can pay. So we can do while paid is less than S. Oh, sorry, the sum of paid. Apologize. Let's go over here and do sum of paid. Okay, and then we can get to work on what's going to happen inside of our loop. As I mentioned, we're going to want to keep track of the current price. So let's go ahead and set a variable of current. And as I mentioned, we can use this counter in a pretty powerful way. So our current will be set equal to P, the initial price that we're going to pay, and we will subtract D times the counter. D times our counter. Because our counter is going to be something that we manipulate, and as we buy a new game, the counter will go up. And what happens when you buy a new game? Well, the next game is cheaper, and the next game is cheaper by how much? It's cheaper by how many games you've purchased. So if you purchased 1 game, that means you get a discount of you get 1 discount on the next game. So you take the initial price and you subtract that single discount, and that will give you the current price for that next game. Okay, And what is our condition, right? I said that this is going, the price will happen in that manner. The price will happen with the discounted manner unless we have reached our floor, our minimum. So we've got two conditions, right? We've got if current is greater than M, our minimum, our floor, we will do one thing, and else if our current is equal to or less than our floor, we will do another thing. We will use that floor value. Okay, so we're going to be appending things to our paid array to keep track of how much each game costs. So what would the first thing we would do be? We can increase our counter. If we get here, this means that we have bought something or we have tried to buy something. So if current is greater than M, our counter will go up by 1. It means we've purchased a game, plus equals 1, sorry. And the cost of that, the cost of the current game should be added to our paid array. So we can go ahead and do paid.append current. Okay? And that's only going to happen while our current is greater than M. Because once we get to a scenario where our current is equal to M or less than M, we can add to our counter, or we don't really, oh, okay, we could return, we're actually going to return the counter. We're not going to return the length of paid in the end. Let's increase our counter again every time we buy something in this criteria. And what would we do? We would paid, that one didn't go. We would paid dot append M. So while we're meeting this criteria, we're going to keep appending the current price to paid. And then what happens? After we exit this criteria, the current price becomes M no matter what, and we'll just keep on appending M to our paid array. So let's go ahead and print our paid array. This might show a little caveat. I can't remember if it does or not. Okay, there we go. There's our paid array, and let's also print the sum of our paid array. I think this will reveal the slight caveat, and there you go. We get 82. What's wrong with 82? Well, 82 is greater than our S. S is how much we came to the store with, how much money we had to spend. So that means we wind up in an interesting scenario that we can solve using another conditional statement. We can say if the sum of paid equals S, because that's possible. We could wind up in a scenario where we've spent exactly what we came to the store with. We will simply return our counter. But what's the other scenario? The other scenario is what we just ran into, where we actually wound up buying one more item than we could. And the reason this is going to happen is because of this condition. Here we wound up at 76. Up until this point, we had spent $76. We had spent less than we came to the store with, which is great. So you go to buy another one, and then what happened? You went over. You broke the Price is Right rules, right? And how could we resolve this? Well, you were fine until you bought that last item. So what you can really do is just go ahead and subtract 1 from your counter. So else return counter, because counter is keeping track of the number of games you purchased, but you bought one too many. So what you would do is just you would return counter -1. Okay, so I hope that's clear. I hope that's making sense. Let's go ahead and copy and paste this over into Hackerrank and see if it solves our algorithm. Let's do some bumping over. There you go. Bump that over. Bump this over. Bump this over. Bump this over. Bump this over. Get rid of these prints. We don't need those. And our returns look good. So let's go ahead and test out our sample test cases. There you go. We passed both of our sample test cases. Run it against all of our test cases. I'm pretty sure there's a bunch here. And awesome. Looks like we passed all of those. So like I said, I hope that's clear. I hope that's making sense. If you have any questions at all, please feel free to pop your questions down in the comments below. If you like this video, if it helped you out, please go ahead and hit the like button. And of course, we are currently covering algorithms at any given day. So if that's where you are also at in your career, please go ahead and hit the subscribe button and follow along. I'm sure we will be able to help you out at some point. Thanks so much for watching, and hope to see you in the next one.